Question 1. Ali and Beth divide £280 in the ratio 2 to 5. We have to work out how much each person gets. Well, if we have a ratio 2 to 5, then first we can count how many parts we are splitting it up into. So we have 2 parts to 5 parts, which makes 7 parts in total. So the idea would be to work out what one part would be worth. Well, if we have £280 and we divide that into 7 parts, we'll find out what one part is worth. And we can do 280 divided by 7 without a calculator. And 4 sevens are 28, so the answer is going to be 40. So that is £40 per part, and if it helps you can write per one part. And so we know now that if Ali had 2 parts for Beth's 5 parts here, then we can simply say that Ali had £80 because it's just twice 40, and Beth would have 5 lots of 40, which is the remaining 200. And the other nice way of doing these questions is, once you've got Ali's share, if you're in a rush, you might lose a method mark, but if you're in a rush, you can just state that Beth would have 200 because 280 makes 280. Okay, so that's a nice start to the paper. Question 2. We've got some information and we have to try and work out the size of angle X here. Well, we're given that this triangle is isosceles because these two sides are the same. So ABE is an isosceles triangle. One statement that we can make is that we know the angles on a straight line add up to 180, which I'm not going to write down every reason here. So if you just listen to how I'm saying the statements, you can write them in your own words. So I know that angle ABE, or you could write this, angle ABE, like so. So we're talking this angle here. Well, we can know that 142 plus that angle must make 180. So a little bit of working, we do 180, take away 142, and we'd get 38 degrees for the reason I've already stated. So we can label that one here. Now the nice thing about this triangle being isosceles is that these two base angles will be the same, and of course you'd write that sentence down. And it's also worth noting that this exterior angle here is always the sum of these two interior ones. So it helps us quite a lot because we can deduce then that each of these are 71 degrees. Now, what other facts can we use here? Well, one nice one is that if we look at this shape here, we have a Z angle. Now, when I was a teenager, we were allowed to say Z angles, but in this current age, we have to say alternating angles or alternate angles. So if we see this, alternate, and it's got 3 syllables, so alternate, that's how I remember it. We can say, okay, this must be 38 as well for that reason. So we'd say angle BEF is 38 degrees, and we'd just say alternate angles. So we've got all we need now, because we have this angle here as 71, this one here 38, and we know if we added those two up we'd get 109 degrees. So we've finally found X, and I'm sure you can see that's now 71 degrees. And the reason being that angles on a straight line add up to 180, and just by looking at this question for the first time, there's so many different options. I can even say, look, here's another alternating angle or an alternate angle. So we could have just stated that angle DEA is 71 degrees because they are alternate angles. Okay, so there's many options here. So kind of how you start is how you finish, but basically if you just look at the diagram, try and work through it really clearly, write down all your statements one after the other, you will get there in the end. These questions are relatively easy because the diagrams are really giving you clues all the time, especially that these were the same length. That really helps. Question 3. We're given a triangle and we have expressions for the lengths, and it says here the perimeter of a square has the same length as the perimeter of this triangle. So let's just draw that square here, and we'll just call its sides y for now. So it's y by y, and that will be the square. Okay, so first of all, let's work out the perimeter of the triangle. So if we add up all the sides, so we've got 2x plus 3, 5x minus 2, and 5x plus 3. Well, we can see here we've got 5, 10, 12x, and then 3 and 3 is 6, take away 2 is 4. So we can see here that the perimeter of the triangle is 12x plus 4. But it says that the perimeter of the square that we've drawn here has the same length as the perimeter of this triangle. Well, we know the perimeter of this square is just 4 lots of y, because they're all y for each length. Now, we are told then that they are equal, so we should find an expression now in terms of x for the length of the side of the square. So all we have to say is that 4y, the perimeter of the square, is exactly the same as the perimeter of the triangle. And if you divide both sides by 4 for this equation, you will have y equals 3x plus 1. Another way of looking at that is, if you factorise 12x plus 4, you'd get 4 lots of 3x plus 1. And then you'd be able to see here clearly that if you divided both sides by 4, you would get the desired result, y equals 3x plus 1. So I think that if I was in the exam, I would just write down the expression again, because don't forget an expression doesn't have an equal sign, and I would just underline that here. Okay, so that's question 3. Question 4. This is quite a difficult question, I think, but let's have a go. We've got a diagram of a swimming pool, and it says the swimming pool is in the shape of a prism, and the swimming pool is filled with water at a rate of 5 litres per second, and we just want to work out whether Jeremy has 10 hours to fill the swimming pool. Will he completely fill it in 10 hours? So why don't we just work out the volume first in terms of litres for the entire swimming pool to be filled up. So I think one way to look at this would be to say to ourselves, well, if we look at the dimensions here, we've got this must be 5, because this was 15 and we've already got 10 here, and if this is 1 and this is 3, then this here must be 2. Now hopefully you recall that the volume of a prism is one of the faces pushed back uniformly, i.e. it's the same shape that's being pushed back all the way, it's not changing. So for example, if you chose this face here and pushed it back all the way this way, then I'm afraid it wouldn't make the same shape that we have of the entire swimming pool, whereas if we do the red face here and push this back by 10 meters, we will indeed create the entire volume that we want. So I'm going to find the area of the shaded part and then just times the answer for that by 10, and that will be the volume. So first things first, I'm going to do the rectangle part first. So that's just going to be 1 by 15, which is obviously 15, and that's going to be meters squared, because it's 1 metre by 15 metres. And then this part here, the triangular part, well, that's going to be base times height, or base times height, doesn't matter which way round. So we're going to have 5 metres by 2 metres. And then don't forget, base times height halved is the area of a triangle. So we're going to have 10 metre squares divided by 2, which is 5 metre squares. So all in all, we have 5 metre squares and 15 metre squares makes 20 metre squares, and I'm going to times that by the depth or the length, whichever ones we've got left. So in this case we have 200 metre cubes, okay, of volume. So let's look back at our diagram so we're completely safe with this stuff, so we know what's going on. I found the area of this part here, the area of this part here, added those two areas together, and then multiplied it by the length that I need to push back to create the uniform prism. So that's 200 metres cubes. Now it says here that 1 metre cube is 1,000 litres. So that's not too hard to work out, that the total volume is going to be 200 times 1,000, which is 200,000 litres. Okay, so that's the first part done. We've found the volume of the pool. Now we're going to look at some of the instructions here, and it says the pool is filled with water at a rate of 5 litres per 1 second. So if I wanted that in minutes, so that's going to be 1 minute. Then I've got to times 5 by 60, so that's going to be 300 litres in 1 minute. And then if I want to create hours here, I've got to times that by 60 again. So 60 minutes would make me 1 hour. So 300 times 60. So think about this. 3 times 6 is 18, but I've got 100 and another 10 more under multiplication, so that's going to be another 1,000. So that's 18,000 litres in 1 hour. So what am I going to have in 10 hours? Well, that's okay. I've just got to times it by 10 both sides to keep the proportion. So I'm going to have 180,000 litres in 10 hours. So will he completely fill the swimming pool in 10 hours? No, he will not. Okay, and you've underlined all your working there, so that should be fine. Okay. Question 5. It takes 12 men 5 days to complete a job, and we have to work out how many days it would take 3 men to complete the same job. Now, before I even begin here, I've got to do this part B first. One assumption that I made was that the men work at the same rate throughout. So basically, what it took the 12 men to do, then each men of those 12 men would be working at the same rate as what the 3 men do. Okay, so if you think about it, if you had more men involved and they were all working at the same rate, then if it took 12 men 5 days to do something, then if you have less men, but those men are working at the same rate as the ones before, the other 12, then it's going to take a lot more time, isn't it? So how can we work that out? So 12 men, well, we're given that is 5 days. So one way of looking at this is we've got to get to 3 here. So if we want to get to 3 men here, then we can divide this by 4. But if we're dividing the amount of men, i.e. making it 4 times smaller in terms of the workforce, but that workforce is working at the same rate, then isn't it going to just take 4 times longer to complete the job? So in this respect, we've got to times this one by 4 to get the desired outcome. So that will give us 20 days. Well, the last part is, how will your answer be affected if your assumption is not correct? Well, I think, these questions are quite hard for me, because I kind of think of all these possibilities. I guess if they weren't working at the same rate, then it could take a lot longer, or be much quicker. So I will go for a simple answer and say, if they do not work as hard, it could take longer. Okay, just go with one of the options and that will be absolutely fine. Just use your common sense really, but try and write in full sentences if you can, although it's only 1 mark. Question 6. Graham has a fair red 6-sided dice and a fair blue 8-sided dice. The red dice can land on 1, 2, 3, 4, 5 or 6, and the blue dice can land on 1, 2 up to 8. Now Graham is going to roll both dice, and we've got to complete the probability tree diagram. One thing to say is that if you have the singular of dice, it really should say die here, but I think if it did, because it's so commonplace for students to see the word dice in the singular, they would probably be put off and think that there was a spelling mistake or something, so just be reminded of that. So let's fill in the tree diagram. Well, to land on a 6 for the red dice, then there's going to be 1 in 6 options, so 1/6 of the time, and that would mean that not landing on a 6 would be what makes it sum to 1, i.e. certain that it was either 6 or not 6 together. So if it's 1/6 for landing on it, it's going to be 5/6 not landing on a 6. And for the blue dice, to land on a 6, there's going to be 1/6 out of those 8, so 1/8 of the time. So it must be 7/8 to not land on a 6. But then if you had have done not landing on a 6 first, then landing on a 6 for the blue dice, you would have the same outcome again, so 1/8 and 7/8. Now what we want to look at, and one of my videos on probability explains why you multiply at the junctions, and it's all to do with cars landing in particular, parking rather, in particular car parking spaces, having started all off from here. Okay, so you can have a look at that in one of the playlists if you wish, or look at someone else's explanation, that's fine. But we want to work out the probability that neither dice will land on a 6. So it just can't land on a 6 at all. So the only route that we can go here is not and not again. Okay, so that would be 5/6 of 7/8. And one way of thinking about it, if it was cars, you would say that 7/8 of the 5/6 that got to this particular place would have ended up here. So I'll say that again. 7/8 of the cars that arrived here would have ended up here had they started at this particular place. Okay, so just imagine these are like roads that the cars are driving down. Okay, so 5/6 times 7/8, well, that's simply going to be 35/48, and that will be 2 marks for that. So 2 marks and 2 marks, that's 4 marks for the whole question. So let's have a little look here at the whole thing. Yeah, Okay, so that was quite a straightforward tree diagram there. They can be a lot more difficult than that, so beware. Question 7, I'm going to do a tiny little mini lesson on that before we begin. If you have a quadratic sequence with 1, 2, 3, 4, 5 and so on up to n terms, and if we think that it's in the form, we won't say ax squared actually, we'll say an squared plus bn plus c, then we can choose numbers for n, i.e. n could be 1, 2, 3, 4 and so on, and we can substitute those into this quadratic form here. So let's see quickly what we get. So if n is 1, we're just going to have a plus b plus c. When n is 2, we're going to have 2 squared, which is 4a, plus 2b, plus c. If n is 3, we'll have this, 9a plus 3b plus c. If n is 4, 16a plus 4b plus c, and so on. I won't bother doing the fifth one. Now the interesting thing to think about when we look at this question is, if we look at the first difference, i.e. delta 1, so the difference between this term and this term is literally 3a plus b. And if we look the difference between this term and this one, we have 5a plus b, and then we have 7a plus b. So if we look at the second difference, delta 2, then we can see that we have 2a. Ah, but look, this one's 2a. In fact, the next one would be 2a, and so on. Now, the reason I've said that, looking back at the question we have, so if I just enlarge this one back to where we were going here, I said to you here, if we look at the first difference, delta 1, we get 3, 5, 7, 9, 11, 13. But look at the second difference. They're all 2. So what does that tell us? Well, if we did it with any expression, i.e. any quadratic expression, an squared plus bn plus c, what did we find? We found that we always get 2a. So if we want to find the value of a, i.e. how many square terms we need, we have to do what? Well, look back at what we had. We had a second difference of 2, but we always know that that's equal to 2a. Therefore, in this case, I hope the penny's dropped, that this 2 would have to be put equal to 2a, which would mean that a would be 1. So we'd definitely have something to do with one lot of n squared, or just plainly n squared. And if I do the square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36 and 49. And if I do a quick comparison to the one lot of square numbers to where I need to be, which is 3, I can see I need just 2. If I look at 2 squared and to compare that to where I need to be, I need to add 2 again. In fact, look, it's always adding 2 more each time. So my expression would simply be one lot of the square numbers, i.e. n squared, always adding 2. And it's worth noting that in this case, here, a was 1 and b was actually 0. There wasn't a linear part in that expression that we wanted, and c was 2. So that gave us one lot of n squared plus 2. There was no linear part involved this time around. Whereas maybe in another paper, or the real one you're going to get in June, maybe there will be a linear part as well. So let's look at the next part of the question. It asks us to find the 50th term of this sequence. Well, that would be when n is 50. So without a calculator, I'm sure we can do 50 squared plus 2, well that's just 2,500 plus 2, which is 2,502. Question 8. We have to work out 2 3/4 multiplied by 3 1/5. Well, let's get this fraction just in quarters, and let's get this fraction just in fifths. So 2 is 8/4, and the 3/4 that we've got already, that gives us 11/4. We want to multiply that by, well, 3 is 15/5, and the 1/5 that we have already gives us 16/5. And then with multiplication, it's nice and easy. We can look to see if anything cancels. You might not want to do that. You might just want to do 11 times 16, which is 176 over 20. It doesn't say give your answer in simplest terms or simplest form, but if it did, then I would suggest you would write this 11/4 times 16/5 as 11/5 times 16/4. It's exactly the same, because when we do multiplication the order doesn't matter, and we can see that 4's into 16 is 4, because 16/4 is 4 whole ones, and that would be the same as having 44 over 5, or 44/5. So either one would be acceptable, whereas I would probably say this one here. Alternatively, if you don't want to rewrite the fractions in different ways, you can just cancel the 4 and the 16, which you've probably done quite a lot of before, and then you'd end up with 11 times 4, which is 44, and then this here would be a 1, and that would be 1 times 5, which is 5. Exactly the same answer. Question 9. I find this question quite difficult, so I might just draw a little table to help me here. If we have liquid P, liquid Q, and liquid R, we know that the mass of liquid P for 1 litre is P grams. So if we just write 1 litre here, that's P grams. And for liquid Q, the mass is Q grams for 1 litre. Then we're most of the way there, I think, because we've got to look at the ratio 3:7. So liquid R is made by mixing a volume of liquid P with a volume of liquid Q. And we've got to work out what the mass of 50 litres of liquid R would be. So if we had 100 litres, then P and Q would be in the ratio of 30:70, wouldn't it? So if we wanted only 50 litres of liquid together, then we'd have to halve this one and halve this one, and we'd get 15:35. So what we can say is here that if we wanted 15 litres of liquid P, then we'd have to have 15p in terms of the mass required. Because if 1 litre was just P grams, then 15 litres would be 15p grams. And then likewise, if we actually wanted 35 litres of liquid Q, then if we know 1 litre was Q grams, then 35 litres would be 35 Q grams. So it looks as though the total mass of those 50 litres would just be 15p grams plus 35 Q grams. So you don't have to write the G here and here, because the actual unit of measurement is given there in terms of grams. So 15p plus 35q should be absolutely fine. Question 10. Here are three rectangles, A, B and C, and they seem to be getting larger each time. And it says the area of rectangle B is 10% greater than the area of rectangle A. So it looks as though the multiplier would be, you'd have to times by 1.1. Because don't forget, if I have a quantity and I times it by 1, it remains to be 100% of what it was to start with. But if I have a quantity and times it by 1.1, then what I'm actually doing is timesing A by 1 plus 0.1, and this 0.1 is the actual 10% added on, if you see what I mean. Because if you did A times 1, you'd be left with where you started, and then 10% more, i.e. 0.1 more of A, would add that extra 10% on. So the multiplier is timesing by 1.1, and then the area of rectangle C is 10% greater than the area of rectangle B. So it looks as though whatever B was, we've got to times that by 1.1 again to add 10% on from what B was. So it looks as though to get from A to C, well, we've just got to times by 1.1 and then 1.1 again to get to C. So 1.1 times 1.1, well, 11 times 11 is 121. So 1.1 times 1.1 is going to be 1.21. So it looks as though if we times A by 1, we'd end up with A, and this 0.21 here means that it's been increased by 21% overall. Well, first of all, we're going to draw the cumulative frequency graph. So it's always the end point versus the cumulative frequency, and there's plenty of videos on explanations for why that is. I think in some of my earlier papers I've given fuller explanations. So let's have a look. 10 versus 0, so that will be here. 20 versus 7, so I'm just going to enlarge this a little bit here so I can get this accurate. So 20 versus 7, so 7 is here, and then 30, 20, 40, 64, so let's have a look, 40, 64, and then 50, 74, and then 60, 80. I've also said in previous exams that when you're trying to draw your ogive, which is a fancy name for your frequency graph, try and draw underneath the arc. So what I'm trying to do is here, you can turn your page when you do it, but I'm going to start from this part here, and I'm just going to carefully go underneath from here. I then will turn my page and then just go underneath this part here, and then I'll try and join these other ones up. And here's where you've got to be careful, not too careful, but just careful enough that it's nice and smooth. So here goes. It might take me a few times to do this. One tip is hold your breath when you're doing that, because it just helps you steady your hand. I don't know why, maybe it's just me that it works for, but give that a try. But don't hold your breath too long. And then you can put your graph there ready, and then we can get ready for the next part of the question. And it says Jane expects that it should take her X minutes to go from her home to school each day. On 25% of the days last term, Jane took longer than X minutes to go from her home to school. Use your cumulative frequency graph to find an estimate for the value of X. So I think this is quite difficult to interpret, but don't worry too much. We had 80 days in total, so if we do a quarter or 25% of 80, that gets us up to 60, doesn't it? Because it goes 20 is 25%, 40 is halfway, 60 is 75%, and so on. So if we read up from 60 here, then we know we're at the 75% mark, then all of this will be the 25% left. So we'll go along, and you can use your ruler here. I don't have one, so I've got to be careful, and then read down, and then you can look carefully at what you see here, and the figure that I have here is 39 minutes. So it looks as though the value that we wanted for x was, now read the question again, Jane took longer than x minutes to go from her home to school. Well, if we go to the 25% mark, then we're 39 minutes or more for 25% of the remaining time. Okay? Question 12. Mark has 18 bags of counters and 12 boxes of them. And it says the mean number of counters in all 30 of the bags and boxes is 14. And it says the mean number of counters in the 18 bags is 10. I find these questions really difficult, especially difficult to explain. So let's have a go. Let's say we have bags and boxes. So let's do this statement first. I think this is the easier one. That if we look at the 18 bags, so bag 1 up to bag 18, that's the counters in those bags. If we divided that by 18, it says the mean is 10. So we have all the counters in each of the bags up to bag number 18, divide that by 18 to find the mean, and that's 10. Well, that would mean that the counters in bag 1 added up to and including bag 18 would have to be 18 times 10, which is 180. Then this statement here, so we've got all the bags and boxes together. So we have the bags here all the way up to the 18th one, and then all the boxes, box 1 up to box 12. And if we did the mean, i.e. divided by 30, it says the answer is 14. So that means that bag 1 up to bag 18 and all the boxes as well would have to be 30 times 14, which is 420. So that would mean that if we found the difference between 420 and 180, we'd get 240. So that would mean that would be the total number of counters in all of the boxes. But how many boxes were there? Well, if 240 is how many counters there are in all of the boxes, then if there are 12 boxes, as it says here, the mean will be 240 divided by 12, which is actually 20 counters per, let's just get that right, per box. So after all of that, is Mark right? No, he is wrong. Okay, so quite a tricky question to explain, but I hope you understood it anyway. Question 13. There's a couple of ways of doing this question. One way is to say that this is 0.4 and 0.03 recurring. Now we know 0.4 is 4/10, and well, what's 0.3 recurring? Well, 0.3 recurring is 1/3 or 3/9, and so 0.03 recurring is going to be 1/30. So we could add those two together. We could multiply this one top and bottom by 3 to get the denominators the same, and that would leave us with 12/30 plus one more, which would be 13/30ths as required. An alternative method would be if you let x equal 0.43 recurring, then 10x would be 4.3 recurring. And if we wrote that like this, and here we have the x here, then we can see if we took them away, we'd have 9x would be, well, all of these would cancel, and then we'd have 9x is 3.9. So that would mean that 90x would be 39. So x would be 39 out of 90. And we can show that that is the same as 13/30ths because we could just have divided top and bottom by 3. So that would be the same as 13/30ths. I'm sure some of you have got some other ways as well, but there's 2 ways for you. Question 14. Jan has some metal that she's going to make into solid metal spheres. Now the volume of a sphere is 4/3 pi times the radius cubed, as we've got here. And it says each sphere will have a radius of 2.15 centimetres, and Jan has 1,490 centimetre cubes of metal, and this is a non-calculator paper, so we've got to work out an estimate for the number of spheres that Jan can make. So the volume of one sphere will be 4/3 times pi times 2.15 all cubed. And what I'm going to do is I'm going to take the 2.15 and I'm going to round it down to 2, and I'm going to use that. So my estimate here is going to be the volume of one of them is 4/3 times pi times 2 cubed, which gives me 4 times pi times 8 all over 3, which is 32 pi divided by 3. And I'm going to take pi as 3, which is again a rounding down, so that will give me here 32 times 3 divided by 3, which is 32. And I'm going to say that as an estimate that is 30, which is another rounding down. Now I've got, well, Jan has 1,490 centimetre cubes of metal, so 1,490, I'm going to round that up to 1,500, and then I'm going to divide that by the 30 here, which gives me an estimate of 50 spheres, because I can cancel these by 10 top and bottom, and 3's into 150 is 50. But the second part of the question says, if you calculate the number of spheres accurately, how do you think your answer to part A will change? And that's 1 mark. Well, this is a little bit tricky to answer really, and it's only 1 mark, so I don't want to go into too much detail at all. I think I will just say I have rounded down more when the denominator was used, so I would actually have less spheres. Okay, now what I mean by that is, if we are dividing by a number, say x, and we have a number at the top y was 1490, and I only changed that to 1500, which was very small change. However, for the denominator, I involved the number pi, which I rounded down to 3, and I had 2.15, which I rounded down to 2, but that was cubed, so I rounded it down really, in effect, 3 times as a multiple. So I rounded down the denominator, x, a lot more. Now, in reality then, that denominator would have been actually much greater than it was. Well, not much greater, but greater than it was. And if I divide a number by something which is getting bigger, then I'm going to get a small answer as a total. So for example, if I just stuck this at 1490 and I divided it by 30, well, that's worth some particular number. But if I take the numerator and keep it at 1490, but actually say this was 33, then it's like I've got a number divided by more things in equal parts. So it's like I've got this many cakes, but more people turn up. So I'm actually going to get less. So I don't like that for 1 mark really, and I think that would be quite difficult to explain. But there you go. This paper I think is quite difficult overall. Question 15. We've got to find the value of this expression here, and this numerical expression, and we're looking at the 4th root of some number in here, which we can also write as to the power a quarter. So we could do 27 times 3, which is 81, and then just write that as 81 times 10 to the 8. Now the 4th root means that we have something times the same thing times the same thing again times the same thing again gives 81 times 10 to the 8. Well, luckily 81 is 3 to the power 4, so I can write a 3 in each of these. If it helps, I'll put little brackets around here. You don't need them, but we'll put them in. And then if you look at 10 to the 8, well, isn't that 10 squared times 10 squared times 10 squared times 10 squared? So what's the 4th root of 81 times 10 to the 8? Well, it would have to be 3 times 10 squared, which is just 300. So for part B, we've got to find the value of 216 1/1000ths to the power negative 2/3. Well, the first thing I would do is look at the negative sign here, which enables us to work out the reciprocal. So that would be the same as writing 1216ths to the power positive 2/3. And then if you think about this, in the previous question, when we had 1/4, that was like doing this number to the power 1 and then finding the 4th root, which would end up here. So in this case, what we could have done is do 1000 over 216 squared and then do the cube root. However, I say to my students, why square and then cube root when you can cube root and then square? So you could do 1000 216ths, the cube root of that first, and then square that answer. And that would be better, because the cube root of 1000 here is 10, because 10 times 10 times 10 is 1000. The cube root of 216 Well, don't worry too much. Just think, is it 3? No. Is it 4? Well, 4 to the power 3 is 64, so no. 5 to the power 3 is 125. If you think 10 to the power 3, well, that was 1,000, so that was far too much. So after choosing 5, you might have to work out one like 7 if you thought it was. And if you work that out by hand, you'd get 343, which would be too much. So if you just tried 6 times 6 times 6 by hand, then you would get 216. So it would be 10 sixths. But the nice thing about 10 sixths is that's the same as 5 thirds. And then at the very end, you can just square it. So you end up with 25 ninths would be the answer. Question 16. Here we have to make t the subject of this formula. So let's have a look. The first thing we can do is multiply both sides by t minus 3. Let's then multiply out the brackets. Now let's get the t's on one side of the equation, and here it doesn't really matter which side, but I'm going to take 2t from both sides. And that will give me kt minus 2t minus 3k equals 6. I'm then going to get the k term that only has a k term, nothing to do with t, on the other side, so I'm going to add 3k to both sides here. And that's going to give me kt minus 2t equals 6 plus 3k, or 3k plus 6. And here's the interesting part, I can see t now as a common factor here. And now all I have to do is divide both sides by k minus 2, because this is a timesing relationship here. So that will leave me with t is equal to 6 plus 3k over k minus 2. Or you could say that's equivalent to 3k plus 6 over k minus 2, or even still you can take out 3 if you want as well. So all of these are fine, and there'll be others as well. Again, I think in one of the playlists I've got quite a few videos on rearranging formulae and making different letters the subject of that formula. So have a look at some of those. Question 17. Well, when looking at this question, try and think what's apparent in both parts of this expression. Well, hopefully you can see there's an x minus y bracket going on here, and there's also one here. But if I write this in this way, which is exactly the same, then you can see that if I take x minus y out as a factor, then I'm just going to have 3 lots of another x minus y remaining. And if I take x minus y as a factor out of here, I'm just going to have minus 2 left. Okay, so again, if you want to check this out, multiply it back out and you'll have 3 lots of x minus y times x minus y, which is x minus y all squared, minus 2 lots of x minus y, which is what you've got. So we can know for sure that x minus y is a factor. I'm doing a square bracket here to show the difference between that and the curly brackets. So I'm going to multiply this bit out here. And then I've got to understand here that I'm not multiplying here because that's multiplied using the bracket because it's 3 times all of this, and then take away 2. Now, I don't know if that's completely necessary to do it that particular way. Part of me is thinking that I probably could have left it at this line here. So if I just write this more clearly, my question is, could I have just left it as this? Well, I think that's okay, because I can see clearly here that I've got my x minus y, and I can see it here also. I think most people feel they have to keep multiplying brackets out all the time, because they just don't like seeing the bracket here. They just want to multiply it. But then I think maybe that's a little bit too much work to get to here. But I haven't checked the mark scheme. I haven't got that with me at the moment. So I think I would say this would probably here be more popular, but this would probably be okay as well. Okay, and don't worry about these types of brackets. You can just leave your answer as something like this. This then is like a nested form. When I say nested, it's because this bracket is nested inside this bracket here. Okay, so have a little practice at those types of questions. It's quite difficult sometimes to see what the mark scheme would look like, and of course that's how the examiners mark your questions. But sometimes if you just do what it's asked, and that's exactly what you've done, then even if that's not on the mark scheme, which could happen, you'll have shown all your workings and you're more than likely to be getting the 2 marks here. So if we move on to part B, let's have a look at this one. So straight away I'm thinking, well, maybe I'm going to factorise this. I think this can be factorised, and I'm going to watch out for this. So first things first, I'm going to try and factorise this into 2 brackets. And the reason is because it's got to simplify to something with a single denominator as a linear expression, i.e. just a multiple of x plus a constant. So I'm going to try putting 2x here, x here. I want to have negative 15, and so these 2 numbers here multiplied together should give negative 15, but I want to have a collective of 1x. So I could use a little grid here. I'll try something like 3 and 5 and see what happens. Well, this will give me 15, this will give me my 2x squared, but I want to somehow have a difference of 1. So if I call this 5 times 2x is 10x, 3 times x is 3x, well, I'll get my 2x squared, but if I want to have a negative 15 here, then say if I made this negative 3, this would have to be plus 5, then this would remain 10x, but this would become minus 3x, and unfortunately that would give me 7x here, and I've got to have 1x. So I'll think of the factors of 15, so 5 and 3, and what I'll do is I'll switch them round. So I'll call this one 5 and this one 3. So how would this grid change? Well, I'd have 2x minus 5 and x plus 3. So if I multiplied those out, I'd have 2x squared, I'd have 6x, minus 5x, and then minus 15. Of course, assuming this is positive here, because there's no sign given. And let's check this. 2x squared, yes. Negative 15, and then the nice thing is that 6x minus 5x is the 1x that I wanted here. So it's going to be 2x minus 5 times x plus 3. And of course you'll have your own ways of factorising, and if you're not still sure on that, then have a look at some playlists from other people. I think I've got a couple of videos on that myself, but other people have done it much better than me, and have a look at those. So for this one, use divide, and okay, now factorise this. Well, you can see that there's a 3x as a common factor, and I'll be left with x plus 3 here. So that's looking good. Now, the other thing to notice is, if I've got a fraction, say 1 over 2x minus 5 times x plus 3 here, and I want to divide it by this number, that's the same as timesing it by the reciprocal of this fraction. So that's going to be 3x, lots of x plus 3 over 1. Now, I often get asked this by students, why is that the case? And one simple little aside is, and if you want to go forward on this, just press the forward key and you can skip this part. But if you had something like a half divided by a quarter, i.e. how many quarters go in a half, which we know the answer is 2, then if we write it like this, what we can do to a fraction to make it equivalent is we can times top and bottom by the same number. So if I times this top number by 4, I'd have to do this number by 4 to make it equivalent, and I will have a half of 4, which is 2, divided by a quarter of 4, which is 1, so the answer would be 2, just like we expected. So the idea here is we can just say a half divided by a quarter is the same as a half times 4 whole ones. Basically, we use the reciprocal of this. So because we know that, we can have a little look here. Yes, I can see something that cancels. So x plus 3 here and an x plus 3 here. Why does that cancel? Well, because on the top here I have 1 multiplied by 3x multiplied by x plus 3. Multiplication, the order of that doesn't really matter. So underneath I could write 2x minus 5 multiplied by x plus 3, which I could just write directly underneath here, and then you can see here that x plus 3 divided by x plus 3 is the same as 1, and you can either write the 1 here and here if you want, or just leave it out. Okay? And what are we left with? Well, we're left with 3x divided by 2x minus 5. Okay? So there's plenty of different ways of doing that, but don't just blindly do something without understanding why you're doing it. And if you don't like my explanations and they're a little bit too long, then just use the forward key and jump forward a few seconds, and then you can just get to the answer if that's what you prefer. Let's have a look at the next question. Question 18. We've got to show that this number here can be simply written as root 3, which looks very difficult. So let's have a go and see what we can do. The first thing I would do is look at the denominator here and get the denominators of this denominator to match. So times top and bottom by root 3 here, and that would give me 4 all divided by 1 plus, well, root 3 times root 3 is just 3 all over root 3, because that's my common element here. And then just studying this a little bit more, I've got 1 plus 3, which is 4. Now, that looks a bit strange, and it doesn't look very much like this just yet, but it will do, trust me. So if we look here, let's make this line a little longer here. So this is the same as 4 divided by 4 over root 3. And there's another question that I did a little while ago on this paper, which was all about doing, I think it was an algebraic expression divided by another algebraic expression, and I explained a little rule there that we can use, and that is we can say that's the same as 4 times the reciprocal here, and then look what happens. 4 divided by 4 is 1, and I've got 1 times root 3, which is just what we wanted, root 3. I'm sure there are plenty of other ways you could go about doing that, so maybe give it another go, trying a different way, and see how you get on. Question 19. we've got to prove that the sum of the squares of any three consecutive odd numbers is always 11 more than a multiple of 12. Well, let's first of all break this down. Let's look at three consecutive odd numbers. Well, an odd number is something like the 2 times table, which is 2n, say plus 1. There's an odd number. But the very next odd number is going to be 2 more than that number, isn't it? So the very next one is going to be 2n plus 1 plus 2, because the gaps between all the odd numbers have a gap of 2, like 1, 3, 5, 7, 9, and so on. And the next one, to make it consecutive, will be 2n plus 1 plus 2 plus 2 more. So we'd have 2n plus 1, 2n plus 3, and 2n plus 5. You could have had 2n plus 11, 2n plus 13, and 2n plus 15. So I'm just going to go with that just to show that it doesn't really matter. And we want to prove that the sum of the squares, so the sum of the squares, so you might regret me choosing these larger numbers now, but don't worry, we'll be fine. And we've got to show that's 11 more than a multiple of 12. Well, let's just multiply these out. So we're going to get 4n squared plus 44n plus 121 here, plus 4n squared again, plus 52n plus 169, plus 4n squared plus 60n plus 225. And then if we add these up, 4, 8, 12, well that's useful, 12n squared, 44 and 52, that's 96, and 60 is 156, n, and then 121 and 169 is 290, plus 225, that's going to be 515. So let's have a look. 11 more than a multiple of 12. Well, I know 12s go into 12 once. I also know that 12 13s are 156, and if you don't, that's okay, because you could have used 1, 3 and 5 here, and these numbers would have been a lot easier, but I'm just trying to show you that it doesn't matter. So I can look at this expression here, and I can write it as 12 lots of n squared plus 13n. But then the sneaky thing here is, why don't you just write 515 as 11 plus something? Well, there's our 11, and 11 plus 504 would work. And then here's the really nice trick here. Does 12 go into 504? Well, 504 divided by 12 is 252 divided by 6, which is 126 divided by 3. 6 and 2 and 1 make 9, which is a multiple of 3. And so 3's into 126 will be 42. So I can write this expression here as 12 lots of n squared plus 13n plus 42, because that's 12n squared plus 156n plus 504 plus 11. And here's the wonderful thing here. This is 12 lots of something plus 11. And what did the question want? It said 11 more than a multiple of 12. Now, the thing that students find difficult is you don't have to worry too much about this part here, because it's dependent on n, and n can be whatever you want it to be. So whatever this number turns out to be, say, I don't know, 1,000,002 or something, who cares? We're timesing it by 12, so it's going to be a multiple of 12 no matter what we had in here, and then I'm just going to add 11 to it. Okay, so I guess what you should do is, why don't you try and use 3 other consecutive odd numbers, maybe start being inventive and say 2n minus 5 plus going up by 2, You can go down by 2 if you want, and then you can go down by 2 again, because they'll be consecutive, i.e. next to each other on the number line, and try doing those and show whether that's a multiple of 12 with 11 added to it. It will be, and I suggest what you do is, to prepare yourself for these questions, is be a little bit more inventive and don't just go for the really obvious route, because sometimes the most obvious route is the hardest route to actually see. Normally you see the easy way when you see a mark scheme or something. So just try and be a bit inventive with your own maths and give your own hunches a try. So go with what you think and give it a go. So question 20, we have a trapezium where OACD is a trapezium. So O to A to C to D is a trapezium, and OACB, so OACB is a parallelogram, and it says B is the midpoint of OD. So we've also got to notice that M is the midpoint of CD. So that's the diagram, and we're given that OA is A and OB is B. So we can get started here. Now, given that BM is some multiple of OC where K is a scalar, just a scalar just means a number without any dimensions. It's certainly not a vector, so it's just a number. So use a vector method to find the value of K. So we've got to try and find BM, OC, and see how they differ from each other. That's basically it. So we know that B to D is also B, because we know also that OB is the midpoint. So because B is midpoint of OD, so if we want to go and find B to M, well, how are we going to try and work that out? Well, the nice things we know is that because that was a parallelogram, we know that this is B also. We know that this is also A. So it's going to be quite hard to get this question wrong. I personally would try and find B to A first. And to get from B to A, then we can just go minus B plus A, which is just A minus B. And we also know then that D to C is going to be the same because they're parallel. So I can put that in. So we're going to be lucky now, we can find O to C straight away. So if I want to go from O to C, I can just go this journey here. So B plus B plus A minus B. And that was the journey O to C. So what have we got here? We've just got B plus A, or A plus B. So if I want to go B to M, then that's that journey here, and I can just do that in this way and just go B plus half of A minus B, because M is the midpoint of CD. So plus half of A minus B, and that's just going to give me B plus a half A minus a half B. So the B minus a half B is just a half B, and I've got plus a half A. So now I can compare these. So I've got OC is just all of A plus B, and I've got BM that's just a half of a plus b. So it looks as though our scalar here, k, is a half. Question 21. It says the length of a rectangle, so let's draw this rectangle out. It says the length of that rectangle, let's call it L, is the same as the length of each side of a square. So let's have a square here, obviously not to scale, and we'll call that L each of those. And it says the length of the rectangle is 4 centimetres more than 3 times the width of it. So if that's the width, we know we've got to have 3 of those, 3 times the width, with 4 more added on. And that will be 3w plus 4 as well, because they're the same. And it says the area of the square, so that means 3w plus 4 all squared, because that's the value of what L is, which is the length of the square, is 66 centimetres more than the area of the rectangle. And the area of the rectangle is just w times 3w plus 4. So just to recap, the area of the rectangle with 66 more added on is the area of the square. So it looks as though we're going to have a quadratic in w, which is more than likely going to factorise, and then we can just work it out from there. So let's have a look at how easy that's going to be. So we've got 3w plus 4 all squared is 66 plus w lots of 3w plus 4. So to square this out, we'll have 9w squared plus 12w times 2, because we've got the bits in between, and I did that purposefully to make people aware that we've got to not just have this one and this one, but you've got to have 12w and another 12w plus the 16, and that's equal to 66 plus 3w squared plus 4w, which is just this multiplied out. So we'd end up with 9w squared plus 24w plus 16 is 66 plus 3w squared plus 4w. Let's get everything onto the left hand side. So we'll take 3w squared from both sides, and that will leave us with 6w squared here. We'll take 4w from both sides, and that will leave us 20w here. And we'll take 66 from both sides, so that will be minus 50 equals 0. I can see that these are all even, so I'm going to halve them all. And then I'm just going to try and see if it factorises. I think for this amount of marks, 6 marks, you've probably done enough by now to not have to do completing the square or something really tricky. So we'll put a 3w in here, a w in here, factors of 25, 5 and 5. So that will give us positive 15w minus the 5 will give us the 10. So we have from here, w is 5/3, or w is something impossible because it's the length of a rectangle, a width of the rectangle rather, so that's not going to be possible. So we're going to stick with this one, and we've got to look now what it's asking for. It says find the length and the width of the rectangle. Well, the width is going to be 5/3 centimetres, and the length is going to be 3 of those plus 4. Well, that's nice because these cancel, and that gives us that the length is 5 and 4, which is 9. So I'd say width is 5/3 of a centimetre, and the length is 9 centimetres. Question 22. Not a nice question to end with. I don't have any notes in front of me on this one, so I'm just going to go for it and see what happens. So I'm going to drop down a perpendicular here and do the same here. And so these would be kind of like parallel to each other if I was to carry these on. The reason I'm doing that is because it says that the area of triangle AXB is the same as the area of the triangle AYB. Now they share a common base here, so if they had this base and then this was the height of the top triangle, base times perpendicular height halved is the area of that top one. But if we had the same base here, I'll change the colour, the same base here and a perpendicular height, and we times the base by perpendicular height and halved, if those areas are the same, it means that these must be the same as well. So that's quite, I think that's quite important. Okay, so we know that if we call this P and this Q, we know that PY must equal XQ because areas of AXB, triangle AXB, and triangle AYB were the same. I'm going to put in an angle here, theta, and I'm going to call this one theta as well, and the reason I can say that is because they are alternate angles, 3 syllables, alternate angles, so I'm going to mention that. You can write a better sentence there. So alternate angles is used. So we've got 2 right angle triangles now. So in triangle PMY, we can say that tan theta is opposite, which is PM, over adjacent, which is PY. And in triangle XMQ, we can also say that tan theta is MQ over XQ. Now, because they're both equal to tan theta, we can say that PM over PY is MQ over XQ. But we already know that PY and XQ are the same, so we can deduce that, therefore, PM equals MQ as PY equals XQ. So the numerators must match if the denominators are exactly the same. Now, because we know that, we also know that we can state that triangle XMQ and triangle PMY are congruent, and I shall use side angle side. I'll just explain that. This side, this angle, and this side are the same as this side, this angle, and this side. Okay, hence ym equals mx. So I can write that down. Now, if ym equals mx and pm was equal to mq, then that means that xy must bisect AB at M. And if you think about it, we've shown that this length is the same as this length, and AB goes through here at M. So M would be the midpoint of XY, and to be the midpoint, if AB goes through it, then it must bisect it into 2 equal pieces. Notice it didn't say perpendicular bisector, it just said bisector, i.e. to cut into 2. Now I'm sure if some of you think I've messed up here, you can send a comment in. It was 4 marks, but I think that was quite a tough paper overall. 80 marks in total. So I hope that you did well on the paper. If not, then look through the paper and then give it a couple of weeks and then try the paper again and see not what you can remember, but what you understood. That's the main importance of doing these papers. I don't think there's any harm at all in seeing a paper necessarily before a mock. It's like a walking, talking mock. I don't know if you've heard of those. But if you really understand the principles, then that's basically what it's all about. There's nothing else to it. That's the whole idea behind you doing these exams in the first place. Not just to remember things, but to actually understand them. So I hope you did well, and good luck.